In example 9, we have ornithologists studying several species of birds, and then they have determined that they need more energy to drive over water. So here it says a bird is released from point A on an island 5 miles from port B, the nearest point on a straight shoreline. So this is the island, point A. 5 miles away, there's the point B on the shoreline. The bird flies to a point C on the shoreline and then flies along the shoreline to its nesting area D, as shown in figure 5. So this is the idea. We were going to see on part B of this problem that it is not possible for the bird to just fly straight from A to D, and it's due to the lack of energy. So the bird is going to fly over the water because the bird can't help it, and then it's gonna fly over the land to reach to the nest. So it says, suppose the bird has 170 kilocalories of energy reserves, and it uses 10 per mile flying over land and 14 per mile flying over water. So the question is, where is this point C, or how far it is from point B that the bird starts flying over land? So is it going to be like this situation, or like this, or like that? The only thing that we know from the picture is that the distance between B and D is 12 miles altogether. So we just need to find how much is this portion. So right here with A, B, and C, I can form a right triangle, and I know this is a right angle because any point, any distance from a point to a line has to be perpendicular. So I'm pretty sure that this is 90 degrees. Just a little refresher on Pythagorean theorem. If I have legs A and B and hypotenuse C on a right triangle, then the following is true. I know that A squared plus B squared equals C squared. So relating this right triangle to the one that we have on the picture, I'm going to call this distance that I'm trying to find X. So A is 5, B is X, and C is, I don't know. So I'm just going to call it question mark. So replacing those values, I have 5 squared plus X squared equals, I don't know, square. And then 5 squared is 25 plus X squared equals, I don't know, square. And then it turns out that the I don't know is square root of 25 plus X squared. And I'm taking the positive because I'm talking about distances, so the distance has to be a positive answer. That's why I'm taking the positive solution here and not the negative one. Now, why am I doing this? Because I want to make sure that I have some expression that depends on X for this distance, because the bird, and here it is, is flying from point A to this point, So the actual variable X is not the one that is going to come into account in my equation. It's going to be some form of X. So the bird goes from here to here, and this distance that depends on X is 25 plus X squared. And then this distance from here to here, if I know this portion is X and the total is 12, this is naturally 12 minus X. And then I'm pretty much done. I can set up an equation. I know that the total energy that this bird has is 170 kilocalories. So I just want to make sure that I'm adding the calories that he's going to spend flying over water, and I'm going to add the ones that he's going to spend flying over land. So I know that this bird is going to spend 14 for every mile, and the bird is traveling 25 plus X squared, square root of that number of miles, plus 10 times 12 minus X miles. That this is the portion over land. So now I'm all set. I can just solve this equation. I'm going to solve for the square root of 25 plus x squared. So I'm going to distribute, and I have 120 minus 10x equals 170 plus 14 square root of 25 plus x squared. And then I'm going to add 10x to both sides. And I have the following. And then I'm going to subtract 120 from both sides. So everything here now is 14 times that square root that I'm trying to solve for. So this will be 50 plus 10x. Now at this point, and you will be right, you will have to divide by 14 on both sides. So that you can leave the square root of 25 plus x squared by itself. However, I'm not going to recommend that, because if I divide both sides by 14, then I'm going to have a fraction here and another fraction here. But not only that, I mean, I can't change it to a decimal because it's going to be some repeating decimal. So everything is just going to be very overwhelming looking. So at this point, I am ready to square, because at least this number 14 is multiplying the root. So it is convenient to square. If it was adding, it won't, because then I'm going to have double the first times the second, and I will still be stuck with a square root. But because 14 is multiplying, it's okay for me to square on both sides at this point. So I have 14 squared times the square root of 25 plus x squared equals this, which will be the first one squared plus double the first times the second plus the second one squared, by those formulas that I already know. Now this will be 196 times 25 plus x squared. Remember that the square will cancel out with the root, and here I have 2500 plus 1000x plus 100x squared. And then I'm going to distribute this 196, and then I'm going to send everything to the right side. Okay, so now simplifying this equation, after I distribute and I bring everything to the right side of the equal sign, I'm just going to combine like terms. So what I have here is negative 96 x squared plus 1000x minus 2400. However, since I have two negative signs, I can change the entire equation signs if I think of multiplying by the number -1. So if I do that, the 0 stays at 0, the negative 96 becomes positive 96, the positive 1000 becomes negative, and then the negative 2400 becomes positive. Now I'm going to apply the quadratic formula, and then I have the opposite of b plus minus the square root of b squared minus 4 times a times c. After I do that, I'm going to have two answers. Either x is going to be 6 2/3 or 3 3/4. What that means is, going back to our drawing, that this point C could be 1 2 3 4 5 6 2/3. So it could be placed over here, and the bird can fly this way, or 3 3/4, which is approximately over here, or C could be over here too. And both ways, the bird will be only spending 170 kilocalories in that trip. So two answers are a possibility. Not always we're going to have a positive or a negative one. It's okay to have two positives, and both of them could be could solve our problem. Now for part B, is asking if the bird just went from A to D in a straight line, would it be able to make it? And I have a larger triangle here with legs 5 and 12, and if you remember, 5, 12, and 13 is a Pythagorean triplet, and if you don't remember that, that's fine. If you solve for x here, you have 5 squared plus 12 squared equals x squared. This is 25. This is 144 equals x squared. So x is either positive or negative square root of 169. And that will be positive or negative 13. And we're going to pick positive 13. So that means is the bird able to travel 13 miles and have enough energy? So because this distance will be all over water, that means that the bird is going to spend 14 kilocalories per mile. And when I do that, let me do it over here. Oh, here's a bird. 13 miles times 14 kilocalories per mile, and that would be 182 kilocalories. Since it only has 170, then definitely 170 is not enough energy to make it, so no, the bird wouldn't do that.